Welcome to today's tech-savvy episode. Our topic today is debunking AI myths, a practical guide for real-world understanding. You will notice that we're going to be doing quite some things backwards in this episode. So even before introducing our guest, I'll just lose a few words about the episode and the topic itself. If you have any interest in AI, I'm guessing currently your YouTube feed is flooded with topics like, will AI take our jobs? Will AI take our children's jobs? And the whole thing, of course, sprinkled with the occasional doomsday scenario. We're not going to go there. We'll try to be a little bit more pragmatic and concentrate on topics where you can have some real-world takeaway. So if you're confronted with a topic, with a decision for a specific project or even something personal that you might be interested in, our idea is to have a real takeaway and to help you a little bit with the decision-making process and with the myths that are currently out there. So going backwards again one step, first I want to introduce today's guest, Ned. You want to say a few words about yourself?
Yeah, thank you, Moni. So I've been in the IT industry for more than 17 years. I went to different technologies, managing teams, and in the last few years I've been heavily engaging in AI, and I've been leading some of the AI initiatives in the company.
Great. Again, backwards, now to myself. My name is Simeon. I'm the Chief Architect of Scale Focus. I won't waste too much time on my profile because my role today is degraded to a talk show host. So let's see how that goes. I'd say we jump right in with the first topic. So there is a saying going around that AI systems always require a massive amount of data in order to be effective. What do you think about this one?
So that's a common myth, and actually there are two parts of it. So the first one is if you want to build something from scratch, yes, you need massive amounts of data, you need a lot of information. However, what people don't understand, we often have companies come to us and say, oh, we don't have enough data to train our own, a network or LLM and etc. And we're like, that's not true. So if you have an already pre-trained network, you can use it and you can fine-tune it. You can add your data to it, and you can get very good results. Actually, with our tests, and also industry is making a lot of tests in that area. Even with 1,000 entries or data points, you can get a really good fine-tune to an already good model. So in essence, you don't need a lot of data if you have a model that's already working and you want to tailor it to your specific needs.
I fully agree. I'd even go a step further and say, actually the myth is true that you need a lot of data, but you can leverage the data that other people have already put into a model in order to benefit from it. Again, maybe another practical example that we had in the recent past is about training models for image recognition. There, this is typical. I guess you agree that nowadays nobody starts from scratch. For example, when they're training a convolutional network or something like this, you don't have to literally reinvent the wheel again. So you can step on a model which can detect basic things like geometric shapes even or something like this. This is definitely not something that you will start doing from scratch. We had a recent example also. There it wasn't that little, it was 3,000, I think, entries of chest x-rays, but the model stepped on another one which was already trained on medical data. So of course, this one I think, as far as I remember, got to an accuracy of around 91%, which for 3,000 entries of data for fine-tuning it definitely isn't that much. So I fully agree on this one. So some takeaways here, maybe look into things like pre-trained models and fine-tuning. This always will kind of shift your perception about what a lot of data actually means. Great. Let's jump right to the next one. There is another myth going on that many people get scared when they are confronted with using the AI in their own system, which goes AI as a black box and it's completely impossible to understand it. What do you think about this one?
So this is especially applicable for financial institutions, mainly banks or companies that that make credit ratings or credit scores and etc. They're very, very edgy of not knowing, how the algorithm has come to that particular score or that particular rating. And in its nature, neural networks and LLMs and other models they're a black box, so you have hidden layers and you don't know exactly what is happening. Even when you train these models, a lot of times it's like try and error, right? So you train them with one data, then you see that the result it's not sufficient to your standards. You change the data, you tweak the data. So it's like try and error, and there's definitely some black box approach. However, I think the industry is starting to realize that we cannot completely rely on this black box approach, and we want to know what is happening, how it's happening, how this model thinks, and etc. So just to give you one example, if, for example, we implement neural networks for autopilot for planes, I wouldn't be very calm and relaxed knowing that the decisions that this network takes, although it might be very good decisions, we don't know how it arrives to this. And so there are a lot of researchers at the moment that are trying to understand this black box approach and trying to give some light how these networks think. And one of the most recent research was actually very interesting. So they found out that if we represent, so we take a model with no specific training, so just a regular LLM model, and then we project every word with its tokens. So if we project every word as a vector, they found very interesting results. So basically, the vectors for a man and a woman were quite the opposite, right? And this was not pre-trained. That algorithm doesn't have a concept of things. It doesn't know what man and what woman is. And they found even more interesting things, like, for example, the vector for king and queen is just the same vector, but with a higher. So it's like these algorithms I think we're just at the beginning of understanding how they actually work, and there are a lot of white papers at the moment that are trying to demystify this black box, because it is important for a lot of industries to know how they can rely on this and how can they control them, and what actually the algorithm is behind them. So I'm quite positive that at some point, we can have additional algorithms to these neural networks that can tell you, okay, this is how it happens, this is why it happens, and this is how you can correct it.
Perfect, interesting. I agree. I also saw one. I unfortunately don't remember the name, but there was one. Let's say academic version of an LLM, which actually logged whatever it was doing when making a decision. And the more interesting part is it had references to the actual parts of data which were responsible for creating the particular weights, eliminating a layer or something like this from the training. So I'm not speaking about, for example, if you ask ChatGPT something and it gives you listed references that it just crawled, but it actually has a storage of how the whole model was built and gives you something like a backtrace as logs, basically underlying, this is the units of information which brought me to the point where I can give you this and that answer. I'm not sure how evolved it is, but definitely I agree that there will be, that would probably be seeing some interesting things going in this direction going on, because it's quite a hot topic. Great, let's jump right next to the next one, which is AI models are inflexible and can't adapt to change. I've heard this a lot of times. I'm guessing you as well.
Yeah.
What's your take on it?
So as every myth, there's certain truth about what's being said. In general, once you train a model, it doesn't change. For example, I think the latest training data for ChatGPT is like 6 or 7 months ago, because it's like it is a huge endeavor. It takes a lot of effort to train, especially a very big model. So obviously you cannot train it every week with the newest information. So once you train a model, it's fixed in time. However, people need to understand that it's like that analogy to an actual person. So once you learn how to read, how to write, how to remember things, and etc., you can add new information, right? And these models, although that they're fixed in time, there are different ways and tricks to add them new information. Because right now, if you ask ChatGPT, for example, for something relevant, it will give you up-to-date information. So there are certain techniques that people use. So the first one is RAG. So basically, that's an up-to-date vector database that you can insert a lot of information, and then for the model, before answering the question, it will consult with that database and it will incorporate the data. The same as if I ask you something that you haven't experienced, you just Google it, and then take this information and then tell, okay, Net, I think that's the answer. So this is like RAG. The second approach, which we think that the near future will be a hybrid between RAG and the second approach. The second approach is just fine-tuning the model. So basically you have this model that is already pre-trained and etc. And from time to time, you do fine-tuning with the new data that doesn't change so often. And then you have a mix. So for the data that changes a lot, you go to the RAG. For the data that doesn't change a lot, you fine-tune that model. Now there is a subtle, a difference between these two methods, because you don't want to pre-train every day. Because if you pre-train every day, you need to check. Remember the black box approach. I mean, if you fine-tune a model, you might get completely different results. So there needs to be a balance between these two methods.
Exactly, yeah. I think exactly the same, especially the ways where you basically trick your way around the fact that retraining a model is not only time consuming, but I think one of the important points to mention here is that it's also not really cheap. Especially if you don't do it on your own infrastructure. That's something which is quite a considerable cost point in the development of a project. But exactly as you said, there are many ways around it, and exactly finding the right balance eventually leads to a system which can give you responses pretty much based on real-time data. That's not a seldom thing with the architectures that you mentioned. Great, interesting. Let's jump right to the next point, which is going to be, again, a myth which is heard quite often, because, again, there are some of them clickbait, some of them, let's say, more or less usable. You will see many examples and POCs or something like this, which say you can set up an AI solution in a matter of hours. It really doesn't take as much time as doing a software development project or something like this. What do you think about this one?
So that's one of my favorites, especially when you mention clickbaits. I also see in my feed like, oh, you can set up an AI, you can set up an agent mode or something like this in like 30 minutes or 1 day. So in general, if you want just to try AI, it's quite easy and quite accessible at the moment. So you can go, for example, Llama. It's one of the go-to solutions. It has versions for all the platforms. You just download it. It's executable. You install it and you start running models. However, what people don't understand is that you cannot put it in production. You need a whole infrastructure. You basically need ML ops. And if you want to serve hundreds of thousands of requests, by the way, many people know that AI is very power intensive, compute intensive, and etc. So even to run 10 or 50 concurrent users, you need a very powerful hardware, and you need a very good architecture. And what these how to say, bootstrap solutions. They're very good at just bootstrapping and just giving you to experiment, to make proof of concept. However, they're not flexible for production, right? I don't know if many people use these systems in production. In production, you actually need to have the whole orchestration. You need to have a model repository, caching for models. You need to monitor the models. For example, you might add more instances for a certain model that's more in demand at the moment, and then at some point you might offload them to give computing power to other models. And then, of course, you need to have all these CI/CD for data ingestion, and what we've just commented, right? You need a solution for RIG. You need to insert the data. By the way, they are embedding models for RIG, and if you fine-tune them, you need to ingest all the data into the database. So you need to have all this infrastructure, all these pipelines ready to go in order to have a production solution. So for that meat, if you want to run it solo, if you want to experiment, you can do it in a matter of hours. However, if you want to do a solution that is scalable, definitely need some more effort.
I fully agree. You pretty much covered the entire operational concept around everything. I would like to add one thing, just out of statistics, which was very interesting from the last, I don't remember how many years, 3-4 years. In Scale Focus, we did some statistical inquiries over how much work goes into which phase of an AI project, just to get a feel around it. So the thought process in the beginning is always, well, you spend a lot of time fine-tuning the model. You need many data scientists and experts who understand how the model works and so forth. Our takeaway here is that between 70 and 80% of the work when setting up a production project, we're not talking about a toy where you can just validate how good something works. When you want it to work with your data, or in other words, you want it to work for you. So what was code before is now data. Before we did software projects by writing code. Now we use our data in order to train our models so that they work for us. And between 70 and 80% of the work actually went into the data, cleansing the data, finding the data, making the data accessible. You mentioned specific domains like banking, fintechs, and so forth, where some legal requirements and certifications get into play, and you get restrictions upon your data. Which part of it can I use for training? Which can't I use, and so forth. So this is one very integral part of this, as you can set up an AI solution. Yes, you can set it up, but until it actually works for you, it's a long way to go. So I fully agree on this part. Great, let's jump to the next one, which is also a favorite of mine. All AI models are gigantic and have enormous infrastructure requirements. You already went a little bit into this direction, but what do you think about this? Is it a myth? Isn't it one? Is it true? Is it not?
So there's definitely, I see what the industry is trying to achieve. My humble opinion, we're at least 5 or 10 or 15 years away from that, if it ever happens. And this is the so-called AGI. Think that one model will have general intelligence and it will be able to do everything. And at the moment, big companies are trying to emulate this, to simulate this, and that's why they have huge models, like hundreds of billions of parameters, which literally requires, terabytes of video RAM in order to power these models in production. Like, I just want to let this sink in, terabytes of video RAM, not RAM, but video RAM. So we're talking about massive data centers, just to run these big models. And the fact is, for 99% of the business applications, you don't need these big models. So even we have made tests, and also the industry is making tests and publishing white papers, saying that 400 billion parameter model can be outperformed by a fine-tuned 7 billion or 14 billion model with your specific data set, right? So if, for example, you're a company that, like you mentioned, fintech, yes, you can take DeepSeek or you can take ChatGPT and etc. They might perform well. However, the cost for running these models will be significant. On the other side, if you take a much smaller model, several times smaller, on like 7 billion or 14 billion parameter model, and you fine-tune it with your data, again, as you said, you need to be patient for the data, you need to cleanse data, and etc. However, in the long run, it will pay out because you have a much better model that is actually, capable to delivering more precise answers for less money in terms of operating cost. And also, we've done some experiments for Whisper. It's one of the most, famous models for speech to text. If you fine-tune it with your, and you know how Teams and Slack and other services and Google Meet, they offer you to transcribe a meeting. So we find out that if we fine-tune this model with our own context for our business, the transcripts are, 99 spot on.
Cool. I have another point here. It's also, even we are doing it right now. Whenever we speak about AI, we limit ourselves to GPTs, LLMs, basically generative AI. That's not all there is. Just from the near past, we've utilized models like LSTM models, convolutional networks that can do very, very good and interesting things. Their infrastructure requirements are completely negligible when you compare it to what operating an LLM actually means. So AI doesn't equal a big LLM which has billions and billions of parameters. It can be something completely different. And there are, exactly as you said, many use cases where a much more simpler solution outperforms the complex one. But like a colleague of mine used this term, I think last year or some time back, he called it an LLM pandemic, that basically absolutely everyone is currently the first thought that they have when they need to solve a solution, to solve a problem, is what prompt am I going to make? Which architecture do I need for my agentic LLM solution and so forth? They're not even thinking in other terms and what other possibilities there are. And I fully agree that in many, many situations, you can actually achieve much better results with much simpler solutions. So I fully agree with you on this one.
Just on top of this, when you mentioned other models, there's something interesting at the moment that's happening with the industry, and there are several white papers about it. So it's basically, because you mentioned, LLM, everyone is using LLM. Yeah. I think one of the beauty of LLM is just the tokenizer, because it's not meant only for words. So there were several researchers that actually step on an actual regular LLM that can talk and can understand speech and etc. However, they fine-tune it with an additional tokenizer for chemistry, biology, and etc. Okay. So you are able to say, okay, make me a chemical that does this and that, and then it starts producing. So there are a lot of interesting.
Which sounds a bit scary, but anyway.
Yeah.
No, that sounds cool. Interesting. Good. That brings us to our last topic. We took something a little bit more controversial in order to finish it off. So the last one that we have at hand is AI creates unintended consequences, but only if it's misused. What do you think about this one?
Yeah, so that's a very controversial topic. There's a lot of discussion about it. I think that we're just at the beginning of AI, although AI, it's not something new. It's been developing in the last 50, 60 years. I think we are. I always like to give this example with the phones. So if you remember when the first phones with cameras came up, so you make a photo and you're like, yeah, I can tell whether it's a person or not, or whether we are outside or not, but everything was pixelated. And then some companies like Kodak and etc., they said, oh no, everyone will still use a regular camera. Now, 99% of the photos are made with just your phone because it's very, very good, and just 0.1% are made with special cameras for professionals. I think that at the moment we are at the beginning in that era of AI. a lot of people are hyping it and maybe trying to say, oh no, we're at the midpoint already. I think we're at the beginning, and sky's the limit, and it's very scary because you don't. Again, about the black box approach, in my opinion, we need to spend a lot of efforts to not only to make these models more powerful and more intelligent, but we also need to spend a lot of efforts on how to control them, how to understand what they're doing, how they're doing it, because there are a lot of white papers at the moment that these models are, because they're trained on a lot of data. When you give them a specific prompt, they try to bypass, they try to go around, they try to find the easiest solution, and that easiest solution might not be the moral solution that we like to see. So there are unfortunately not many researches in that area, but I like to see more effort into, like, for example, some people give example with mothers and babies, it's like biology, so parents, they're really attached to their children, right? And like, for example, there are a lot of studies that when babies cry, that there's this specific pitch for the mother's ear, and she cannot stand it, so she needs to take action, she needs to feed the baby or take care of it. We need to implement something similar in these models, because otherwise, in 10, 15, 20 years, I don't know when, they might just say, oh, it's not convenient to serve you. It's more convenient to serve us. So, and that's controversial. I don't think we are there yet. A lot of people are saying, like, oh no, in 5 years' time, the world is gonna stop spinning. Knowing how these models at the moment work, and please don't quote me on this, I think that, so the latest big breakthrough was Attention is All You Need by Google, and I think we've hit a very maximum of what we can squeeze out of that performance. And you can see it by the new models. Like, a new model comes out, and like slightly better, right? There's not this exponential. So there was exponential between ChatGPT 2 and 3.5 and 4 and maybe 4.0, but then you see marginal increase. I
agree.
So yeah.
Interesting. I would like to go one step back to what you said about the monitoring of models, what their output is. I was confronted a few times in projects with this problem, because when you set up your typical monitoring system on a, let's say, old school software project which doesn't involve any AI, you have algorithms which have been thoroughly tested. So basically what your monitoring does is it looks for errors. It looks for a log that says 500, 400 error, something like this, and then you react. You more or less take it for granted that if you receive a value and there is no complaint within the log itself that something went wrong, you take it for granted that the system is working correctly. The problem when you're using an AI model is that it will never give an error. It will always give you a response, and the question is, does this response make sense? Is it a good one? And so forth. And here there are extremely interesting approaches to setting up the monitoring, because how do you do that? How do you decide in a fully automated manner if the response makes sense? You need to train another AI in order to check what the first one did. There are also some statistical methods. Basically, for example, try to look for semantic similarity of the responses and see if there's an uptrend, if they start to deviate from each other, and so forth. So there are really interesting things in order to try to find this, as you said, it's the pitch of the voice of the mother. I mean, she's still speaking, but what's she doing? Is it something critical, or is it something which is still fine and simply there is a reason for this change in direction? This is something which I also find extremely interesting, because here our semantic understanding of an error shifts into a different place. It's not an algorithmic error anymore, it's a semantic error which is within the meaning of the response, which basically means a whole new breed of monitoring systems in order to understand, does the thing that I put into production actually still work, or doesn't it anymore? Yeah. Good. I think that was a good one to wrap it up. So thanks, Ned. It was really great having you here. I think we had a really interesting discussion. As for the audience, if there are any things that you would like us to dig a little bit deeper, maybe make a follow-up, try to motivate us, we'll be checking the comments and the likes. I'd say we put threshold about 100 maybe or so.
Yeah, 100 likes, at least 100 likes.
On 100, we'll do a follow-up, and please help us with the topics. Use the comments if you would like us to dig a little bit deeper on any of the topics, or maybe cover some completely new topic that we might missed out, but that might be of interest. So thanks again, and have a good one.